So I've pre-drawn the diagram for this problem because it takes a little bit of time to draw, and just for the sake of saving that time, I've drawn it earlier, and I can just explain the problem from here. Or you can pause the video and read it. Basically, we're given that a triangle ABC is acute, and we have that a orthocenter is at H, and we're given that we have the circumcircle of HBC, and we look at the tangent line to that circumcircle being x and y, and then we're given that hx equals 2, hy equals 6, and ha equals 3. And we're asked to solve for the area of triangle ABC. So the way we want to approach this is we realize that altitudes are going to be an important part of the problem. Otherwise, you probably wouldn't talk about the orthocenter. So our best bet for finding an area formula for this triangle would be of the form a half base times height, right? So which height might we go for? You can see that we already partially have um, AD in this case, right? We know that AD AH is 3, so we can maybe find AD, and the way we might think to do that is we draw out A, the line AD, and we extend it all the way until it reaches circumcircle omega again at point A prime, let's call it. So why do we do this now? Well, we do this because we know that HBC, this triangle, is going to be congruent to BA prime C. And the reason for that is we can see that by drawing out the altitudes C, H, and BH. So if we extend those to be the full altitudes, they form perpendiculars here, we can see that, let's call angle ACB gamma. Then we look at this triangle EBC. If ECB is gamma and BEC is 90, then that must mean that EBC, the angle, is 90 minus gamma. And we apply the same logic here to find that angle FCB is 90 minus beta, where beta is going to be ABC, angle ABC. And what do we notice? Well, since B, H, and E are collinear, then angle EBC is the same as angle HBC. And the same goes for F. So angle HCB is actually 90 minus beta. And we can now see that actually, if we look at the arc that is subtended by BAA prime, that's going to be the same as the arc subtended by BCA prime. So these two angles are congruent to each other, right? And now you might ask, well, what is this angle, BAD in this case? Well, we know that because ABC is angle beta, then angle BAD is going to be 90 minus beta because ADB is 90 degrees here because it's an altitude. So what does that mean? That means now BCA prime is 90 minus beta as well. And the same here, we have 90 minus gamma. And since BC is the same side, the same corresponding side for both triangles, we see that HBC, the triangle, is congruent to A prime BC as well. And from there, we can also draw the conclusion that, okay, that must mean that if we look at line BC here, right, then A prime BC is a reflection of HBC across the line BC. And what that also means is that the circumcircle for A prime BC is going to be a reflection of the circumcircle for HBC across the line BC. So the circumcircle that we were given in the problem of HBC is, when reflected across BC, the same circumcircle as that of BA prime C, except the circumcircle of BA prime C is going to be the same as the circumcircle of ABC, or just omega, which means that the circumcircle of HBC, we'll call it omega prime now, is congruent and a reflection of omega along line BC. Okay, so now from all of this, let's actually just erase these lines here because they really complicate the diagram and we don't need them for the rest of the problem. So let's remove all of this. So from here, what we know that is important is that HD and DA prime have to be congruent because they're both reflections across the line BC. So this is X and this is X, right? And I think I erased this too here, right? So now by power of point, we know that AH times HA prime, so that's 3 times 2x is equal to HY times HX, 6 times 2, which means x is equal to 2, right? So now we can replace this here. We have 2 and 2. And we can also form a relation between BD and DC using power of point. Let's call BDX. Let's call DCY. XY is equal to 2A prime D times DA 5 or 10. So now we have XY is equal to 10. You can erase the middle part. Okay, so why does this help us? Well, we know now the value of AD, right? This is the altitude that we were thinking might be useful to find, and we just found it. So now we have this H and the half. So now all we have to do is find B, or in this case, BC. And BC is equal to x plus y, and we know that xy is equal to 10. So this might help us in finding BC, either just by knowing that y is completely dependent on x. So y is equal to 10 over x. So if we just find x, we could solve the problem. And we could even solve the problem if we were to find, say, x minus y. Actually, since y is bigger, y minus x. If we were to find y minus x, then we could also find x plus y using our knowledge about xy. Okay, so how might we find x in this case? So if we draw out BC, extend it outwards, and we also extend out line xy such that it intersects this line, we get point Z. And why is this significant? Well, since H and A prime are reflections of each other, this means that ZH and ZA prime are also reflections of each other. And what do we know about ZH? Well, we know that line XY is tangent to circle omega prime, which means ZH is also tangent to circle omega prime. So the reflection ZA prime is going to be tangent to the reflection of omega prime, and that is omega, which means ZA prime is tangent to omega. So if we refer to ZA with some variable, actually it would be easier to label ZX in this case. Now Z looks too much like a 2, so let's label it W in this case. So if we're given that ZX is W, then we have that ZA prime is equal to W plus 2. And since it is tangent to circle omega, then we can use power of point again. So we know that W plus 2 squared is equal to W, or ZX, times ZY, or W plus 8. And we have that W squared plus 4W plus 4 equals W squared plus 8W. This cancels. This cancels. We're left with 4W equals 4, or W equals 1. So now we have that ZX equals 1 and ZA prime equals 3. And now we actually can find ZD by Pythagorean theorem. So we have that the square root of 3 squared minus 2 squared, that's the square root of 5. So this is equal to ZD, right? And now that we have this, we can realize that, okay, we can apply power of point again, right? Because ZB times ZC equals ZX times ZY, right? And we know most of these variables. So we know that ZX is equal to 1, ZY is equal to, right, 9, and ZB, but we can write that in terms of X and Y here, right? Which is what we're trying to solve for. So we know that ZB is equal to the square root of 5. So that means ZB is equal to the square root of 5 minus X, and ZC is ZD plus DC, and DC is equal to Y. So now we have the square root of 5, which is ZD plus DC, Y, is equal to 9. Okay, so now we can expand this out. So we have 5 minus plus the square root of 5y minus the square root of 5x minus yx is equal to 9. And we know that yx is equal to 10. So we have minus 10 here. And let's just actually subtract 5 from both sides. So here we have 4, and then we can add 10 to both sides, and we get that this is 14, right? So now, why is this useful? Well, notice that now we have an expression for solving y minus x, right? And we know with y minus x and xy, we can always find an exact value for x plus y, right? So now all we have to do is do that. So y minus x equals 14 over the square root of 5, right? And now we can square this. If we have y squared minus 2xy plus x squared equals 14 over the square root of 5 squared, or yeah, 196, I believe, over 5. Actually check that. So that's 6, 156, right. So we have that 14 squared is 196. So y squared minus 2xy plus x squared equals 196 over 5. And if we were to find y squared plus 2xy plus x squared, and we take the square root of that, that would give us x plus y, right? And we can find this easily from where we are by adding 4xy to both sides and then taking the square root. And we know 4xy is just equal to 40 because xy is equal to 10. So now we have x plus y squared is equal to 196 over 5 plus 40. So that would make, okay, we have 200 over 5 here plus 196 over 5. Let me make sure I didn't miss anything here. So that's 4, that's 10. Yep, right. So that looks correct. Right. So now we have 396 over 5 is equal to x plus y squared. So x plus y equals the square root of 396 over 5. And 396, okay, we can actually use difference of squares here. We know that 396 is 400 minus 4, which is 20 squared minus 2 squared. So that's 20 plus 2 times 20 minus 2, so 22 times 18, and that's 9 times 2 times 2 times 11. So we see here there's 36 times 11, which means 6 squared times 11. So now we can pull out a 6 from here. So we see that we have 6 times 11 over 5 equals x plus y, the square root of 11 over 5. And now we just need to finish off by finding the area. So 1/2 times BC, which is x plus y, times the altitude AD, which we know is 5. So 1/2 times 6, the square root of 11 over 5, times square root of 5 times the square root of 5. So this square root of 5 cancels with that, and we can multiply these two, and this cancels to get a 3. So our final answer is 3 times the square root of 55. And that checks out with our answer format that we're given. So our final answer would be find m plus n. So that's 55 plus 3, or 58. And we are done.